Hi everybody. So today we're going to talk about the natural base. Okay, so before we do this, I just wanted to remind you that our test on chapters 4 and 5 is next week on Tuesday. Okay, so this is a good section to review for that stuff because it kind of goes over a lot of the things that we've done in chapter 5. And the stuff that we're covering on Thursday night's lecture will not be on the exam. So this is the final section that's on the exam for Tuesday of next week. Okay, so first of all, let's say what the natural base is. Okay, so E is a number. It's an irrational number, which means that it's a decimal that doesn't ever end or repeat. Okay, it's a lot like pi in that respect. And just like pi, it comes up so much that we have a symbol for it. Okay, the first couple digits of E are 2.718. Okay, and then it continues, but it never repeats. Okay, so it comes up so much that we have a special symbol for it. We use the letter E. Okay, so let's talk about how we're going to use this. Okay, people refer to E as the natural base because it comes up in nature. So the natural exponential function is the exponential with E as a base. Okay. We can also use E as a base for a logarithm. Okay, and this is so common that we have a special notation. Just like we do for log base 10, we have a special notation for log base E. So you can write log base E of x, or you can write ln of x. Okay, I just wanted to point out this isn't a special L, that's just how L looks in my handwriting. So if yours looks like this, that is also totally fine. Okay. All right, so let's do an example of evaluating some of these logs. Okay, so remember when you're asked to evaluate this, right, you're trying to figure out what exponent of the base, so the base here is E, is equal to this number. Okay, so when you think about it like that, you can see that the number that would go here is 4. So that's why we're going to put 4. Okay, so let's do a couple more of these. Okay, so again, we're asking what power of the base, which is E, is equal to the inside part, E cubed. Okay, well, you can see you would have to put a 3 there in the exponent, so that's going to go here. Okay, this is when you really remember, okay, logs are exponents, right? So you're seeing the exponent here as the natural log. Okay, let's do a couple more. Okay, so what's going to give you this 1 over type of structure? What kind of exponent gives you a fraction? Remember, negative exponents give you fractions. So this is going to be -3. The negative is coming from it being in the denominator, okay? And then the 3 is this 3 here. Okay, so again, this is asking what power of e is the same as 1 over e cubed, right? We know that's e to the negative third power. So this is asking what power of e is the same as root e, okay? So what type of exponents give you roots? Fractional exponents give you roots. So because this is a square root, our fraction is going to be 1/2. Okay, so let's see a couple easier ones that come up all the time. Okay, so what power of e is e? Well, remember anything to the 1 power is itself. And what power of e is 1? Well, remember anything to the 0 power is 1. Okay, so these ones come up a lot, so I just wanted to talk about those. All right, so let's talk about the log properties. These are exactly the same as the log properties that we saw before, okay? They're just written with the natural log notation. Okay, so those are the 3 main log properties, and again, they're exactly the same as we talked about before. They're just written with the natural log notation instead of log base e notation. Okay, so let's do a couple examples with this. Okay, so sometimes the directions will say expand completely, or you guys have seen in the book, sometimes it will say write in terms of simpler logs. Okay, and those really mean the same thing. They want you to expand it out so that inside the log there's only a single thing and there's no exponents in there. Okay, so let's look at one of those. Okay, so the first thing I'm going to do is split up my product. Okay, and now I'm going to change root z into an exponential form. Okay, and last I'm going to bring out all of my exponents as coefficients. Okay, now there's one more thing we can simplify. You can see we have natural log e here. Remember from the previous example, natural log e is 1. Okay, so that would be my fully simplified form. All right, so let's look at an example of combining things using the log properties. Okay, so sometimes the directions will say write as a single log with coefficient 1, and sometimes they'll say simplify. Those really mean the same thing. Okay. Okay. So I wanted to remind you that with these problems, the first thing you want to do is take the coefficients and turn them into exponents. Okay, and now I'm going to use my exponent rules to simplify these. So 4 squared is 16, x squared. Okay, and when oops, this is a 3. When I have 2y squared to the third power, I'm going to multiply my exponents. Okay. All right. So now that each of them has coefficient 1 or -1, I'm going to combine them into a single log. Okay. So remember, things with a positive coefficient here are going to end up in the numerator, and things with negative coefficients are going to end up in the denominator. Okay. And now you can see that I can cancel some stuff here. Okay. All right. So that's a review of using the log property using the natural log. Okay. Let's review solving some equations using the natural log. Okay. Okay, so I just want to remind you, okay, you are going to isolate the log. Okay. Then you are going to change to exponential form. Okay. And then you're going to finish solving. Okay. And the last thing you want to do is check your solution. Okay. And remember, you're not checking for mistakes. You're checking to make sure that you're allowed to plug that solution in, because you know you can't plug negative numbers or 0 into a log. Okay, so let's do that here. Okay, so here I want to isolate my log, so I'm going to subtract 1 from both sides. Okay, and now I'm going to change it into exponential form. So remember, the base of this log is e, so that's going to become the base of my exponent. Here's my exponent here, equals x. Okay, now in these problems, it's really important to remember what the variable is. X is the variable, e is a number. Okay, so you want something that looks like x equals. Well, we have that here, so this is our solution. Even though it may not look like a numerical value to you, this is a number value. Okay, so let's look at another one of these problems. Okay, so again, I'm going to start by isolating the log. So I'm going to add 2 to both sides. Okay, then I'm going to divide both sides by 3. Okay, once I have my log isolated, I'm going to change to exponential form. So the base of this exponent, the base of the log, which is e, becomes the base of my exponent. This is my exponent here. Okay, and then my answer is 4x. Okay, so now remember, x is our variable. We want to isolate it, so I'm going to divide both sides by 4. Okay, and there we go. That's my answer. All right, let's do one more example of this. Okay, now remember, when you have two logs like this, you want to combine them using the log properties. Okay, so the first thing I'm going to do is change my coefficients into exponents. Okay, and then I'm going to simplify. Okay, now I'm going to use my log properties to combine these two terms together. Okay, so the positive one goes into the numerator, the negative one goes into the denominator. Okay, and now you can see you have p to the fourth over p to the fifth over p to the fourth. You can simplify. Okay, and now we have a single log. So we're going to rewrite in exponential form. The base e, here's my exponent, okay, and then here's my answer. Okay, the last thing I need to do, remember this is my variable, is divide by 32. And that would be my final answer. All right, so there's a little review of solving log equations. Okay, so let's review solving exponential equations using the natural base. Okay. Okay, so let me remind you of the steps. The first thing you want to do is isolate the exponential. Okay. Then you want to take the log of both sides. Okay. And then you're going to finish solving. All right. So first, I want to isolate my exponential, which is this e to the x minus 1. Okay, so I'm going to divide both sides by 5. Okay. Now I need to take the log of both sides, right? Like when we talked about this before. But what base should I use? Well, you want to use this base. Okay, so we're going to use log base e, which is the natural log. Okay. This is from our very first example in this one, right? If you have e to the x minus 1, okay, this is asking you what exponent gives you e to the x minus 1. So it's x minus 1, okay? And you can't simplify natural log 15. That's just a numerical value, okay? And then the last thing we need to do to finish solving this is to add 1 to both sides. Okay, now I wanted to emphasize that there's no way to combine these two terms, so please don't worry about combining those. Okay, let's look at another example like this. Okay, so the first thing we're going to do is isolate this. Okay, so we're going to divide both sides by 2. Okay, then we're going to take the natural log of both sides. Okay, so over here, this is going to simplify. I get t plus 4. Okay, and over here, I'm going to get natural log of 38. Can't really be simplified. Okay, and then the last thing I need to do is subtract 4 from both sides. Okay. All right. So let's do an applied example. Okay, so the compound interest formula looks like this, where A is the amount in your account. Okay, E is just itself. Okay, R is the interest rate. Okay, this is a percent as a decimal. Okay, and T is the time in years. Okay, so let's look at an example of how you might use this. Okay, so you invest $500 into an account that pays 7% interest and it's compounded continuously. Okay, so this is how you know that you need to use the compound interest formula. Okay. Okay, so we're going to write an equation for our account balance, and it tells us that we're going to use the variable A to represent account balance, and T is our variable, our input variable. Okay, so remember we're using this, okay, and we know that because it says compounded continuously. Okay, so here I'm going to use my function notation. Okay, E is the same. Oh, I'm sorry. What am I doing? Got my P in there. Okay, so I don't think I told you guys in the previous page what P is supposed to be. So P is what's called the principal, okay, which is the initial amount. Okay, so here my initial amount is $500, so that's what I'm going to fill in for P. Okay, remember E is a numerical value. I don't need to fill anything in for that. Okay, and then R is my interest rate, so 7% written as a decimal is 0.07. Okay, and then T is my input variable. So this will be my equation. T is my independent variable. A of T is my dependent variable. All right, let's look at part B. Okay, how much will be in your account after 2 years? Okay, so 2 years means that we're going to have T equals 2. Okay, and we're going to plug that into our formula from part A. Okay, now because we're using function notation, we're going to remember to plug in the 2 here as well as here. Okay, Now, after we plug in this 2, we can really enter this right into our calculator just like that, okay? And if you do that, you should get about 575.13 cents. Okay, you know to round it to 2 decimals because you're talking about money. Okay, let's see another question we could ask about this formula. Okay, so we're going to find t such that a of t is 750. Okay, so remember our original equation looked like this. Okay, and we're going to plug in a of t equals 750. Okay, now this is just like the exponential equations that we were solving in the previous example. So we're going to divide both sides by 500. Okay, and now that we have our exponential isolated, we're going to take the natural log of both sides. Again, we're using the natural log, okay, because we have the natural base here. Okay, now over here, all we can really do to simplify is to reduce this fraction. Okay, so these are both divisible by 250, so this is going to be 3 over 2. Okay, and over here, what exponent do you need to raise e to get e to the 0.07t? That's 0.07t. Okay, and then we would divide both sides by 0.07t. Okay, now you do have a natural log button on your calculator, so you can just plug this right in. Okay, and you get t is approximately 5.8. Okay, so that answers the first part of the question, find t. Okay, so now we're going to answer the second part of the question, what does that mean? Okay, so remember, whenever you're answering the what does it mean questions, right, you're thinking about the original question. You have $500 in an account, okay? So remember, t is the time, so we would say after 5.8 years, okay? And then a of t is the money. So you have the a of t was 750, so you have $750. Okay, so 2 parts to the point, the t part and the a part. So there's 2 parts to my answer, explaining what the t is and then explaining what a is. Okay, I hope you guys thought this was a good review, and I'll see you guys soon.